In this video, we're going to look at what happens underneath the hood during initial composition. So far, we've looked at the basic operations of the slot table, but how do they come into play during initial composition? So let's start with an example. Here's a simple example of a composable method that takes in a string value and it displays it. It also calls other composable methods. So what's happening underneath the hood as this is executing? Well, there are three goals that we want to accomplish. The first goal is that we want to create all the groups for all the composable methods. We'll look at how that works. We also want to set up recomposition scopes and listen to the snapshot system for any changes. So we'll look at how these three goals are accomplished one by one by one. So if you take a step back and you look at what are the components in the architecture that are in play as you start to look at how these goals are accomplished. So we have the composition object, which is orchestrating everything. That's interacting with the composer, and the composer is telling the slot table, hey, I want to create these groups. We also have the recomposer listening to any invalidations. So let's look at each one of these components. The first thing that we need to do as you set up compose is to set up the recomposer. The recomposer, its job is to listen to any invalidations from the snapshot system. And in order to do that, we need to be able to set up an observer. That's what this method does, run recompose and apply changes. What it does is that it registers an observer right here. And this is where a recomposition is going to happen. So when the recomposer is starting up, when it's performing changes, it's going to inform external basically components of what it's doing through states. So these are the different states that a recomposer could have: inactive, pending. It starts off as inactive, but when an invalidation happens, the state transitions to pending work, and then during teardown is going to go to shutdown. So the recomposer is switching between these different states. And I can listen to these different states. I can monitor them by listening to a stream. This stream exposes all of the state changes. How do I listen to this stream? The recomposer provides me with a as recomposer info method from which I could take the state and collect from it. So any state changes I could observe basically in this collect method, just like this. This is good for learning how Recomposer is working. So after setting up and registering an observer in the snapshot system, I need to be able to set up and hook into compose, and I'm going to do that by using the composition object, which is like the orchestrator, and it takes in an applier that we'll look at later on, but it also takes in what we just created, the recomposer. And when I call the set content method, that's the thing that starts off basically the composition process. So here's what the code looks like. Our code at compile time has to transform to be able to hook into the runtime, to be able to interact with the composer and tell it to create groups. So this is what the second piece of the compose source structure comes in, where you have the plugin, which is in the Kotlin repo, which is the compose compiler plugin, and it has transformers that are able to basically look at your composable methods and then add in extra parameters, add in extra logic to be able to hook into the runtime. So here's what the plugin would do. At compile time is going to transform this greeting method. It's going to add basically a composer, is going to add in a changed value, is going to tell the composer to create a restart group, and we'll look at what that means. So around basically your function body is going to wrap in logic, bit masking logic, to be able to determine whether to skip the composable method or not, as you can see there. It also adds in logic to skip basically the group. So the plugin is hooking into the compiler, and the compiler allows you to hook into different phases such as analysis, and it's able to do that to be able to transform this composable greeting method. And in the end, it looks like this. So let's look at what each of the lines in this method is doing. What is this generated code doing? It's hooking into the runtime, but what's the goal? The first goal is to be able to create all the groups for it. So I need to be able to create something called a restart group. So the set content method starts off the initial composition process. And when you look at the set content method, that lambda in there is also marked as composable. So what it does, first thing that will do during the initial composition is that the orchestrator, the composition component, is going to tell the composer, hey, I need you now to start to create the groups and start to create the root group. So the composer internally calls this method called root group. And the root key is basically a hard-coded value, which is a key value of 100. So it goes in and basically starts to create a group address space. And it creates a page like this with 64 empty slots. He's going to add in the first group, which has a group address of 0. Then it's going to add in another group, which has a hard-coded key of a value of 1,000. It's at address 1, group address 1. And internally in there, we need to store information. And the information that we need to store is a composable lambda type. And the composable lambda type is actually a function type. And recall that the set content method itself, what it's doing is basically creating an instance of that composable lambda right there. So that's the initial kickoff of the initial composition process. And the next thing that we need to do after creating these groups is to be able to now hook into that greeting composable method. That's what this is doing right there. And what this does is that it begins to call that greeting method as I've shown right here. And what it does is that it calls this method called start restart group. And the question is, what is a restart group underneath the hood? How do you define it? A restart group is basically creates an instance of a recomposition scope in the reference slot, and we'll look at what that means. This is the definition of a restart group. And there are other types of groups we'll look at later on. So first look at restart groups. So what a restart group does underneath the hood, that is telling the slot table, I want to add basically a group for this. And this is what it looks like. And the next thing that it will do is basically going to add a recomposition scope. And this is really, really important when it comes to being able to recompose things. I want to be able to track dependencies, etc. And that's what the recomposition scope is useful for. What it is underneath the hood is that it's actually a class that gets instantiated and internally has state, which is going to be basically the scope right there, which is specified. That's going to get called again during recomposition. And they're also going to have any track dependencies. In this case, for example, the name that composable method is relying on. And what the recomposition scope has is an internal API. It has the ability to recompose, to skip composition, and to invalidate. And this is the API which is called during recompositions. So when it creates this instance, the important thing to know is that it keeps track of the group that it's for. So for example, group address 2. And you want to be able to do that. We'll look at that. We'll look at the purpose of this during recompositions. We want to be able to know which group to be able to recompose. So the way it updates the slot table is calls this method called updates value with the scope. And what that's going to do internally is going to start to add basically a recomposition scope instance in the reference slot, just like this. And underneath the hood, it's using the same slot table operations so far that we have looked at. So what it's going to do there is basically going to create an instance of basically the recomposition scope like that, but it also has to store in the computed value of the name of this greeting. And it does so, and it stores that also in the reference slot, just like this. For example, if it was hello Bob, it would store the string value just like that. So after this, the important thing to understand again is the purpose of this recomposition scope, which is to be able to later on to be able to recompose this, to be able to call that updated scope again, to be able to skip and invalidate. And as the function body is being executed, it is going to then call other composable methods that are part of the hierarchy, like user bio, user detail. It has to traverse down and create more restart groups. So it's going to go into user bio and it's going to create a restart group for that, and also going to create a restart group for details. And once it goes from the top to the bottom, basically, is going to have basically a group address space just like this, where you have more groups with keys in them. And the three and the group number 3, group number 4 represents user bio and user details respectively. And they have basically a reference slots. In the reference slots, they store their own recomposition scopes. So in the end, when you go through this initial composition process, in the end, you get something like this. This is what it looks like. This is a very, very simple example of the group address space, and you can see that there are things stored in the reference slot space right there. There's nothing stored in the primitive slot space so far because there were no primitive values that the composable functions were using. So we have accomplished the 3 goals that we set out to do, which is to be able to create all these groups and set up recompositions, hook into the snapshot system. This is really, really important because it sets everything up to be able to now traverse these groups during recomposition when there's a change that happens in the state. And we'll look at how that works underneath the hood. Thank you. If you want to learn more about Kotlin, coroutines, or Compose, you check out my website at codingwithmohit.com.